So here I want to use question number 3 in homework 2 as an example to show you some probably common mistakes when you solve the questions on perpetuity. So in class we haven't talked about formula yet, but in class we will talk about the formula for perpetuity. So that formula is the present value of a perpetuity is simply payment, which is constant, periodic payment, divided by the interest rate. So the formula for the perpetuity is quite simple, but it's very important to know when can we apply this formula. So the formula applies if I draw this chart, timeline 0, 1, 2, 3, 4, 5, 6, and so on and so forth, continues forever because it is a perpetuity. So we are talking about a perpetuity. So very importantly, we need to understand first payment has to start from year 0 or year 1. Sorry, we stand at year 0. That's our present moment. So to apply this formula, the first payment has to start from year 1 and continues forever. So that's how we apply this formula. So now I want to use an example. As I said, question number 13 in homework 2, to show you sometimes it might be easy to forget what we just talked about. So this question reads, given an interest rate of 5.6% per year, what is the value at date t equals to 7 of a perpetual stream of $4,000 payments that begins at date t equals 15? Okay, so translating those words into this timeline here, this is what it basically means. So this is 0, and this is 7, and this is another date is t equals 15. So this is 15. So the question tells us we have a perpetual stream of $4,000 payments that begins at date t equals 15. So that means the first payment starts from here, and this is 4,000, and this continues forever. Okay, it's a perpetuity. But the question is asking us the present value, right? The value, given the interest rate of that, what is the value at t equals to 7? So right here, relative to date 15, this is a earlier, so we can call that present value, but it's a present value in terms of a 7, year 7. It's not the present value, the true present value in terms of year 0. It is the present value in terms of year 7. So it's asking about this number. So how can we solve this question? Can we directly apply this formula here? The answer is no, because as we said, to apply this formula, we have to make sure the first payment starts from next year. So relative to t, relative to 7, year 7, if we want to apply this formula, we have to make sure the first payment starts from year 8. But unfortunately, that's not the case here because the setup says that the first payment starts from year 15 rather than year 8. So that means we cannot directly apply that formula. And at least not for present value in terms of year 7. But we can still apply that formula, but then we have to move our base 9, right? Similar to what I discussed for question number 12. So suppose we stand at the year 14, okay? So we move our the base 9 to year 14 now. So relative to year 14, when we look forward, year 15 becomes the first year. So now, when we stand here, year 14, the first payment starts from by the end of the year and continues forever. So that's a classical perpetuity. So we can calculate present value in terms of year 14 very easily by applying this formula. But once we have that number, remember we are not done yet because we still need, the question is asking us the present value in terms of year 7, not year 14. But once we have this 14, how can we figure out 7? Again, this goes back to the meaning of present value. Present value, we said in class, means it's the equivalent worth of a future cash flow or a series of cash flows. In this case, it's a perpetual stream of cash flows. So in other words, you give me two options. One is you give me this P present value in terms of year 14, and two, you give me $4,000 starting from year 15 and continues forever for each year. Basically, I'm indifferent between these two options. So once I have this number, present value in terms of year 14, I don't have to worry about these future cash flows. I think just forget about them and just deal with this single individual cash flow. And then, because we need to figure out present value in terms of year 7, so we need to move this back. So relative to year 7, year 14 becomes the future. So then we just need to figure out the present value of that single future value. And then we just need to know the number of years between 7 and 14, and that's 7. So that's our final work. So basically, based on our discussion, we can solve this question by two steps. Step 1, calculate present value in terms of year 14. Okay, so this is very straightforward to do. Present value of year 14, that equals, we can directly apply that formula. So payment, obviously that's 4,000, and the interest rate, what's the interest rate? Interest rate is 5.6%. Okay, so that's based on the setup. Interest rate is 5.6%. So just directly plug in this number. It's 5.6%. So this gives me, just put this into my calculator, 4,000 divided by 5.6 times 100. It's basically I'm dividing by 5.6%. So that translates into multiplying by 100. Okay, so that's so that gives me 71,428 0.57 if I keep two decimal places. I believe that's what the question is asking. Uh, so 71, 428 and 0.57. But remember, we are only getting this present value in terms of year 14. We're not done yet. We still need our second step, which is to figure out the present value in terms of year 7. Calculate present value in terms of year 7. Okay, so based on our discussion, now it should also be straightforward, because relative to the year 7, year 14 becomes the future. So we can just, and since we are only dealing with one single cash flow, so we just need the parameter for the present value of future cash flow times 1 plus interest rate raised to the power of, the power needs to be the number of periods between your baseline year, the baseline is the 7, and the future date, which is 14. So that gives me the negative 7. Just plug in the number. So this is 71,428.57 times 1 plus 5.6% raised to the power of negative 7. So no space. So this gives me, just plug in this into my calculator. I have this number already, so just times parentheses 1 plus 5.6. I don't have a percent sign, so I need to divide it by 100. Sometimes this is very sensitive. So I need a power sign, power, and I need a negative power, which is 7, negative 7. So I need a parentheses again, negative 7, enter. So eventually we have this 48,778.06 dollars. So that's our final answer right here. 48,778.06. Okay, so let me put this number into the connect site to check whether we have got the right answer. 48 778 778.06. Check my work. Yes, we got it right. So I hope by using this example, I have given you some better idea about how to use the formula for the present value of a perpetuity. So we need to make sure that the first payment starts from next year. So if it doesn't start from next year, we have to move our baseline to, like in this case, we move our baseline to be year 14. So the first payment, which starts from year 15, becomes the first payment. Then we can use that formula. And once we have the present value in terms of some baseline year, and then we can further discount that value back to where we need to get the true present value for. All right, so that's it for the discussion.